Okay, so in this lesson, we're going to talk about solving trig equations. So, again, a trig equation is, it's just solving now like you have in algebra classes, but now involving trigonometric functions. So the values that satisfy the equation are called the solutions. So to test if something is a solution, all that we do is substitute that value in. So I have this equation, 2 sine theta minus 1 is equal to 0, and I want to see is pi over 4 a solution. So what I'm going to do is I'm going to substitute in pi over 4. So I get 2 sine pi over 4 minus 1, and I'm checking, does this equal 0? So if I use my unit circle, I know that the sine of pi over 4 is radical 2 over 2. So I have 2 times radical 2 over 2 minus 1. We're seeing, does this equal 0? I know these 2's are going to cancel out, so I get radical 2 minus 1 does not equal 0, which means that this is not a solution. So to check if pi over 6 is, we're going to do the exact same thing and substitute it in. So I get 2 times the sine of pi over 6 minus 1. We're seeing, does that equal 0? So I know that the sine of pi over 6 is 1/2, so 2 times 1/2 minus 1, does this equal 0? 2 times 1/2, those 2's cancel, 1 minus 1 does equal 0. So pi over 6 is a solution. In terms of now being able to determine other solutions, I'm asking myself, is there somewhere else where I get a sine of 1/2? And if I look at my unit circle, 5 pi over 6 is another angle that gives me a sine of 1/2. So 5 pi over 6 is another solution. Now, if I think about just writing these solutions generally, I have a solution of pi over 6. So I know that that is that rotation, but I could also go around another full rotation and end up in the same spot. So another solution would be 13 pi over 6, because that's adding 2 pi. And I could do the exact same thing with 5 pi over 6. If I think about what I have in purple as an angle of rotation, I know that this is 5 pi over 6. If I do another full rotation around, that's going to be adding 2 pi. So that's going to get me an angle of 17 pi over 6. So if we just think about it, we can just keep going around doing full rotations, but our base angles here are pi over 6 and 5 pi over 6. So how we write this is my theta is 5 pi over 6 plus or minus 2 pi k, where k is some integer, or pi over 6 plus or minus 2 pi k, where k is an integer. And again, this is just a very general solution, but it covers all of them. So if I go to my next one, I want to solve the equation cosine of theta is equal to 1/2. So I'm again just asking myself, where do I get a cosine of 1/2? So I can go ahead and do the inverse. So inverse cosine of 1/2. So that gets me on the unit circle pi over 3 and 5 pi over 3. And now again, if we think about those angles of rotation, so if I have a pi over 3 rotation, and I do another full rotation around, that's adding 2 pi, which would be 6 pi over 3, so that would be a rotation of 7 pi over 3. And then if I want to do 5 pi over 3, it's going to be down in quadrant 4. So I get this rotation is 5 pi over 3. And if I go ahead around again, it's going to be adding that 6 pi over 3. I get 11 pi over 3. Okay, so there's 4 of my solutions. I got that pi over 3, 5 pi over 3, 7 pi over 3, and 11 pi over 3. And again, we know that we could write an infinite number of solutions on here, but these are just 4 of them that are going to satisfy that equation. Okay, so now solving an equation. So I have 2 sine theta plus radical 3 is equal to 0. So when you solve trig equations of this linear form, we're trying to isolate sine theta like we get x alone. So to start, what I'm going to do is subtract radical 3 from both sides. So I get 2 sine theta is equal to negative radical 3. And then I'm going to divide by 2. So I get sine theta is equal to negative radical 3 over 2. And then to get theta alone, we know we need to do the inverse of both sides. So this is going to get me theta is my inverse sine of negative radical 3 over 2. And instead now of thinking of all of the solutions like we just talked about, we are now going to be looking on the unit circle, since I have this restriction that my theta is only going to be between 0 and 2 pi. So now I'm asking, where do I get a sine of negative radical 3 over 2? And that is going to be at 4 pi over 3 and at 5 pi over 3. So those are going to be the two solutions for that equation. Okay, going on to my next one. I have sine of 2 theta is equal to 1/2. So I know, again, sine is already isolated, so I can start by taking the inverse of both sides. So now I have 2 theta is equal to inverse sine of 1/2. And again, I have this restriction that I'm solely looking at the unit circle. So I have a sine of 1/2 at pi over 6 and at 5 pi over 6. So I have 2 theta is equal to pi over 6 and at 5 pi over 6. So since I now have two solutions, I'm going to set up two separate equations and solve both of them individually. So I get 2 theta is equal to pi over 6, and I also have 2 theta is equal to 5 pi over 6. And to get theta alone, I need to just divide by 2 or multiply by 1/2. That'll cancel out. That'll cancel out. So that gives me, for my first solution, theta is pi over 12. And then that second solution I get is theta is 5 pi over 12. But now we have a period change. So if we take a look at our b value, I have a b of 2, and we know that the period for sine is 2 pi over b. So if I do 2 pi divided by 2, that's going to give me a period of pi. And since I have these two solutions that are both in quadrant 1, and they're going to repeat every pi, I do have two more solutions to this trig equation. So what I need to do is I need to take these two solutions and add pi to them. So I get pi over 12 plus pi and 5 pi over 12 plus pi. Again, because this period is pi, so it's going to be repeating itself. So if I get that common denominator of 12, this is really pi over 12 plus 12 pi over 12. Or 5 pi, and then 5 pi over 12 plus 12 pi over 12. So that gives me two more solutions of 13 pi over 12 and 17 pi over 12. So this trig equation actually has 4 solutions. Pi over 12, 5 pi over 12, 13 pi over 12, and 17 pi over 12. So anytime you have a change in the period of the function, you do have to make sure that you take that into account and make sure that you get all of the solutions that you can inside of that interval. Okay, next one I got tangent of theta minus pi over 2 is 1. So tangent is already isolated. So I'm going to start by doing the inverse tangent on both sides. So I get theta minus pi over 2 is equal to my inverse tangent of 1. So now I'm asking myself, where do I have a tangent of 1? And I have this restriction on the unit circle. And that would be at pi over 4 and at 5 pi over 4. Or in 5 pi over 4. So I'm going to go ahead and set up these two separate equations. So I get theta minus pi over 2 is equal to pi over 4, and I get theta minus pi over 2 is equal to 5 pi over 4. And now all I need to do is isolate theta. So that's going to be adding pi over 2 to both sides in both equations. So I get theta is pi over 4 plus pi over 2, and 5 pi over 4 plus pi over 2. And now just to add these fractions, I got to get that common denominator. So this is really going to be pi over 4 plus 2 pi over 4. And then 5 pi over 4 plus 2 pi over 4. And that's going to give me my two solutions, which is when I add 3 pi over 4 and 7 pi over 4. Okay, using a calculator. So I still have this domain restriction from 0 to 2 pi. So using a calculator, I know I'm going to have my theta is inverse tangent of -2. So I'm going to go ahead to my calculator. So I'm going to make sure that I'm in radian mode. So mode, radian, and quit out of that. So I'm going to do second tan to get my inverse tangent. I'm going to type in -2. So this value gives me -1.107148, this value is not in between 0 and 2 pi, so we do not care about this solution, but we know that tangent has a period of pi. So what we're going to do is we have this solution, we're going to add pi to it, and that gives me 2.03, and that is in between 0 and 2 pi, so that is going to be a solution that satisfies it. And I'm going to add pi again, and I get 5.18, and that is also in between 0 and 2 pi. So when you're working with a calculator, again, it's just thinking about what's the period of the function, and you're just going to keep adding it until you get outside of the domain restriction that you have. So this one has the two solutions. So theta can be approximately 2.03 and 5.18 radians. Okay, solving equations in quadratic form. So I have 2 sine squared theta minus 3 sine theta plus 1 is equal to 0. So this obviously looks like a quadratic. So what we do in this case is we're going to call our trig value x. So I'm going to let x be sine theta. And now what I'm going to do is I'm going to solve this just like I would solve a quadratic. So I can do 2x squared minus 3x plus 1 is equal to 0. And now we're going to factor this quadratic. So using AC. So AC is 2 times 1 is 2. B is -3. So I'm seeing what adds to -3 and multiplies to 2. That would be -2 and -1. So remember, with these two numbers, we're going to split that middle term. So you get 2x squared minus 2x minus x plus 1 is equal to 0. We're going to group the first two terms together and the second two terms. We're going to factor the GCF out. So I can pull out a 2x, which leaves me at x minus 1. And then we need these binomials to match. So to get an x minus 1, I need to pull out a minus 1. Set that equal to 0. And then we can group together. So I got 2x minus 1 times x minus 1 is equal to 0. And now, since we factored this, we knew that x was equal to sine theta, so we're going to go ahead and plug that back in. So I get 2 sine theta minus 1 times sine theta minus 1 is equal to 0. And now we know from factoring that we're just going to set both of those equations equal to 0 and solve them separately. And do this up here. So I get 2 sine theta minus 1 is equal to 0. And then I also have sine theta minus 1 is equal to 0. So solving that equation first on the left, I'm going to add 1. So I get 2 sine theta equals 1. And I'm going to divide by 2. So I get sine of theta equals 1/2. And then to get that theta alone, we know we're going to be doing inverse. So now I'm asking myself, where do I get a sine of 1/2 on my unit circle? And that would be at pi over 6 and at 5 pi over 6. And solving that second equation, I get sine of theta is equal to 1. And then we're going to inverse both sides. So I get theta is inverse sine of 1. Now I'm asking myself, where do I get a sine of 1? And this is at pi over 2. So this equation has 3 solutions at pi over 6, pi over 2, and at 5 pi over 6. Okay. On to my next one. So I have 2 cosine squared theta plus cosine theta minus 1 is equal to 0. So now I have the trig function is cosine, so I'm going to let x be cosine theta. I'm going to plug that in. So 2x squared plus x minus 1 is equal to 0. So I got a, c, and b. So a times c, 2 times negative 1 is negative 2. And I get a b of 1. So what multiplies to negative 2 and adds to 1? That would be positive 2 and negative 1. So I'm going to take those two, split my middle term. So I got 2x squared plus 2x minus 1 is equal to 0. I'm going to group my first two terms and my second two terms. I can factor 2x out of the first two, so it gets me 2x, and that leaves me x plus 1. And then we need those binomials to match, so x plus 1, to get that I need to factor out a negative 1 is equal to 0. And then I'm going to group those two, so I get 2x minus 1 times x plus 1 is equal to 0. And again, we called x cosine, so we can go ahead and substitute that back in. So this factors to 2 cosine theta minus 1 times cosine theta plus 1 is equal to 0. And now we're going to go ahead, set both those factors to 0 and solve both equations. So I get 2 cosine theta minus 1 is equal to 0, and cosine theta plus 1 is equal to 0. Solving the first equation on the left, I'm going to add 1. So I get 2 cosine theta is equal to 1. And then divide by 2, so I have cosine theta equals 1/2. And then I get theta is my inverse cosine of 1/2. So I'm asking, where do I get a cosine of 1/2? And that is going to be at pi over 3 and at 5 pi over 3. And then solving that second one, I'm going to subtract 1. So I get cosine of theta equals negative 1. And I know that theta is inverse cosine of negative 1. And we get a cosine of negative 1 at pi. So the 3 solutions to this equation are pi over 3, pi, and 5 pi over 3. Okay, now solving equations using identities. So I have the equation 3 cosine theta plus 3 is equal to 2 sine squared theta. So the problem here, based off of the previous equations that we've worked with, is I now have 2 trig functions. I'm working with cosine and I'm working with sine. So we can't do direct substitution like we did, substitute sine for x and then factor it. So what we need to do is rewrite this equation to only have one trig function. So that's where the identity that we talked about, sine squared plus cosine squared is equal to 1, comes into play. Because if I look at this identity, sine squared plus cosine squared is 1, I can isolate sine squared by subtracting cosine squared. So this can get me sine squared is equal to 1 minus cosine squared. And then what I can do is substitute 1 minus cosine squared in for sine squared into my equation. So if I do that, that is going to get me 3 cosine theta plus 3 is equal to 2 times 1 minus cosine squared theta. And we can go ahead and distribute that too. So that gets me 3 cosine theta plus 3 is equal to 2 minus 2 cosine squared theta. If I go and I distribute that too. And now if we're thinking of how we can factor this, remember we need to get all things to one side. We need to get it equal to 0. So I'm going to add 2 cosine squared theta and subtract 2 from both sides. So doing that is going to get me 2 cosine squared theta plus 3 cosine theta plus 1 is equal to 0. And now we can go ahead and factor this just like we did with our last problems. So we can go ahead, we can call x cosine theta. So this is now 2x squared plus 3x plus 1 equal to 0. So if we do the AC method, AC 2 times 1 is 2, and B is 3. So the two numbers that multiply to 2 and add to 3 are 2 and 1. So I'm going to go ahead, split my middle term. So 2x squared plus 2x plus x plus 1 is equal to 0. Group my first two terms, and my second two, factor my GCF. So I pull out a 2x, leaves me x plus 1. And then to get that matching x plus 1, I just need to pull out a 1 is equal to 0. So this factors to 2x plus 1 times x plus 1 is equal to 0. And we know that x is cosine. So if I go, when I substitute that back in, I get 2 cosine theta plus 1 times cosine theta plus 1 is equal to 0. And we're going to go ahead and set both of those equations to 0 and solve them both. So doing the first one, 2 cosine theta plus 1 is 0. I'm going to start by subtracting 1. Sine theta. So I have 2 cosine theta is negative 1. I'm going to divide by positive 2. So I have cosine theta is negative 1/2. And then I know I have, where is my cosine? Negative 1/2. And that's going to be at 2 pi over 3 and at 4 pi over 3. And now doing my second one, cosine theta plus 1 is equal to 0. I'm going to subtract 1. So I have cosine theta equals negative 1. And now I'm asking myself, where do I have a cosine of negative 1? And that is going to be at pi. So the three solutions that I have to this equation are 2 pi over 3, pi, and 4 pi over 3. Okay. The next one I got cosine squared theta plus sine theta equals 2. So we're going to add in a 2 here, only because if not, then we're going to get non-real solutions, and we don't want to have to deal with that right now. So we're going to make it cosine squared theta plus 2 sine theta is equal to 2. So same problem. I have two trig functions. So if I, again, think about that fundamental identity that I have, I know that sine squared plus cosine squared is equal to 1. Now, since I have cosine squared, I want to get that alone, so I'm going to subtract sine squared over. So I know cosine squared x is equal to 1 minus sine squared x. So I can go ahead and substitute 1 minus sine squared in for that cosine squared. So I get 1 minus sine squared theta plus 2 sine theta is equal to 2. So again, we're going to try to factor this. So we're going to subtract that 2 over. So I have negative sine squared theta plus 2 sine theta minus 1 is equal to 0. And factoring this with a negative out front is not going to be the easiest. So I'm going to divide everything by negative 1. And remember, dividing by a negative just changes your signs. So I get positive sine squared theta minus 2 sine theta plus 1 is equal to 0. And now we can go ahead and let x be equal to sine theta. And then I get x squared minus 2x plus 1 is equal to 0. This is one of my perfect square trinomials. X squared minus 2x plus 1 is just x minus 1 squared is equal to 0. So if I go ahead and substitute sine back in, this is really sine of theta minus 1 squared is equal to 0. So to get rid of that squared, we can go ahead and take the square root of both sides. So I get sine of theta minus 1 is equal to 0. I'm going to add 1, so I get sine of theta equals 1. And I'm asking myself, where do I get a sine of 1? And that is at pi over 2. So that is my one solution that I have to this equation. All right, last thing is solving inequalities. So when it starts with, when we start with these inequalities, we're going to treat them like equations in terms of, again, getting the trig function by itself. So I'm going to start by trying to isolate this sine x. So I'm going to start by subtracting 2. So I have 2 sine x is greater than 1. And then I'm going to divide by 2. So I want to know, where is sine x greater than 1/2? So when you have this, what we're going to do is we're going to treat this like an equation. We're going to solve sine x is equal to 1/2. So now again, we're asking ourselves, where do we get a sine of 1/2? And if we look at our unit circles, it's going to be at pi over 6 and at 5 pi over 6. So these two angles are like our bounds. So it's either everything in between these two angles or it's everything outside of the two angles. Okay? So if I think about sine, we know that sine is y. And we know that at pi over 6 and 5 pi over 6, we have that sine of 1/2. So if we think about all the other angles on my unit circle, talking about with pi over 6 to 5 pi over 6, I'm now thinking about those y coordinates, and all of the y coordinates in between are going to be bigger than the y coordinate of 1/2 at 5 pi over 6 and at pi over 6. So if we think pi over 4, radical 2 over 2, pi over 3, radical 3 over 2, pi over 2 gives me a sine of 1. So all of those values would satisfy this inequality. So the full written out inequality is pi over 6 is less than or equal to x, which is going to be less than or equal to 5 pi over 6. Or if you want to write it in interval notation, pi over 6 to 5 pi over 6. And then we're going to put that in brackets. Okay. So last one, I have 2 cosine of x minus pi over 2 minus 2 is less than or equal to negative 3. For 0 is less than x, which is less than or equal to 2 pi. So same thing, I'm going to start by isolating cosine. So I'm going to add 2 to both sides. So I get 2 times the cosine of x minus pi over 2 is less than or equal to negative 1. I'm going to divide by 2. So I get the cosine of x minus pi over 2 is less than or equal to negative 1/2. And then to get rid of the cosine, we're going to now again solve this like the equation. So I have cosine of x minus pi over 2 is equal to negative 1/2. So with this, we knew we did the inverse cosine of both sides. So I get x minus pi over 2 is equal to the inverse cosine of negative 1/2. And we get a cosine of negative 1/2 at 2 pi over 3 and at 4 pi over 3. So this gives me x minus pi over 2 equals 2 pi over 3 and 4 pi over 3. And since I have these two solutions, I have the two equations that I need to solve separately. So I have x minus pi over 2 is equal to 2 pi over 3, and x minus pi over 2 is equal to 4 pi over 3. So to solve both of these, we just need to add pi over 2 over. So I get x equals 2 pi over 3 plus pi over 2, and x equals 4 pi over 3 plus pi over 2. Now we just got to think adding these fractions, we need a common denominator. So the common denominator here is 6. So this is really 4 pi over 6 plus 3 pi over 6. And then I have 8 pi over 6 plus 3 pi over 6. And so when I add, that is going to give me 7 pi over 6 and 11 pi over 6. So I have, these are the two angles that I'm working with. I have 7 pi over 6 and 11 pi over 6. So if we think about them on the unit circle, seven pi over 6 is right around there, 11 pi over 6 is right around there. So I want an x value that is going to be less than or equal to those values there. And again, if we think about these as bounds, we know that the cosine is going to be less than or equal to in between everything in those two angles. So we can write this as 7 pi over 6 is less than or equal to x, which is less than or equal to 11 pi over 6. Or if we want to do interval notation, from 7 pi over 6 to 11 pi over 6, inclusive of both of these.